let me start sharing my desktop number 2, where we will have the the content of our training today. Okay, so where I have the chat here, very good, very good. So it's a pleasure for me to be here. It's the first time to participate in the activity of CPPEX. For this type of activity, actually I'm an independent trainer and consultant within the flexographic process since 2017, and I'm coming from a direct experience within the flexographic process. I would say more generally also with photopolymer plates since 1987, and so counting the 5 years of scholarship this year is ringing 40 bells in of my experience within the industrial graphic arts. And I'm also a consultant and official trainer for the Italian Flex Association, ATIF, and active member of the American FTA, a member of the board, of the technical board of the association, and I'm qualified as certified implementation specialist level 3 with their method called FIRST, flexographic image reproduction specifications and tolerances. Maybe you know or heard of it. And I also collaborate with the Italian TAGA Association, the Association of Technical Experts in Graphic Arts, and FTA Europe, where I'm a member of the technical committee. So today I was requested to bring you some experience in the topic of flexographic printing plates. And we will have 2 sessions, right? One is today and the other one is on Thursday. I really beg your pardon, because initially it was supposed to be on 27 and 28, but I am traveling tomorrow and the day after for a congress in the south of Italy, so it wouldn't have been possible to do it in 2 subsequent days. So that's the reason why we will meet again on Thursday at the same time. These 2 sessions are 2 parts dedicated to the printing plates for flexography. And the first session is much more dedicated to the, let's say, when speaking to the printer. So how the plates should be, what are their features, what are their method of preparation, and so on. The second session, that will be on Thursday, it will be much more dedicated to plate making. So how we prepare our plates, what are all the necessary calibrations and the method for obtaining a consistent result and measurable result within our process. So that would be the audience. The much more dedicated audience is within the repros. Okay, so the repro house or whoever is involved with the making of the flexographic printing plates. So let's get started on this, and I'm happy that we have a good also the recording for the people who registered to this training and are not able to attend at this time. We know that whenever a business trip is coming and calling, you have to go. So same here. So let's start with understanding this the flexographic printing plate. What you will see on the screen will also be released. Tatiana, correct me if I'm wrong. It will be released as a PDF content at the end of the trainings, and what you see here is actually a part of a more complete extended training that we are in the discussion of maybe being able to provide to you in different ways. And I would love to deliver the training as a phase training in classroom by person, because I think that the training online is fantastic. I mean, I got used to it in the last years because of the pandemic situation. But I tell you frankly, The training in person is much, much different, and it gives much more possibility to interaction, and I can see your eyes if you're sleeping, so I can correct myself and I can keep you awake. So trying to make it more interesting and less boring as possible. So if you want to connect with me on socials, please feel free. I'm on LinkedIn. You can find me easily. Also on my website, flexo.expert and flexo.training. These are the websites I use for my activity. But for the purpose of this activity with CPPX Global, it will be directed through the channels of this association. Now, okay, let's speak about the flexographic printing plate. What is a printing plate? A printing plate is actually the element that identifies any conventional printing system. So we classify printing systems by the presence or absence of a printing plate. Printing plate, that is a stencil, something that carries one fixed image and is able to reproduce one certain graphic element at every repeat of the printing impression. Digital printing systems do not have a fixed plate, a fixed stencil. Conventional systems like a gravure, offset, letterpress, silkscreen, pad printing, whatever, they have a fixed printing plate. Therefore, we call them conventional printing systems. And we can reproduce multiple copies of the same subject image. And in the case of flexography, this stencil is characterized by a relief image area and made on a certain flexible and resilient structure. Actually, the name flexography comes exactly from the characteristics of the printing plate. So when in 1952 flexography was invented as a name, because it used to be called aniline printing before, the name was actually given by the characteristics of this flexible printing plate and the rapid drying liquid inks. Now, we have many types of printing plates. Maybe some of you are working with thin plates, some others are thicker, some are harder, softer, some are digital, some are conventional, some are, you name it. We have so many different types of flexographic printing plates, and it's useful to have to start having a kind of a classification of these according to major aspects. The first aspect is how do we obtain the relief layer, the relief image that will print on our plate. The second aspect is how do we image the printing element. So these are two different aspects that we have to consider separately. Now let's start from how do we make a relief printing area on our plate. We can have different methods. One is, we call it additive method. So by way of, typically we will see how it works with polymerization. We harden something that creates a mass of a certain material that will constitute the printing area. Or we can have the subtractive method. So we are removing the non-printing areas, okay? Or we also can have the molding. So we will see like the impression of a certain kind of a embossing using temperature and pressure and time. With these methods, we can have, according to the material that we will use, we can have solid photopolymer plates or liquid photopolymer plates that will realize that we work with the additive system, so constructing or building the printing area. When we have an inert elastomer, we will scratch away or burn away with a laser. So we will subtract and remove the non-printing areas. And then typically when we have molding, we have rubber that we use, well, that was used because we described it as kind of a vintage, okay, method for making plates. Then we have the process method. So how do we remove or how do we differentiate the printing parts and the non-printing parts by the action of a washout, of a development or whatever? And solid photopolymer plates can run with solvent or thermal or water washout, okay? We will see all these details either today or the next time when we will go deeper into the process. Liquid photopolymer is processed with water or with air. It's an air blade that blows away the non-used photopolymer. The elastomer works with a system that we call ablation, direct laser engraving. This burning away of the material by means of a laser beam is called ablation. And then rubber, we can have vulcanization, or let's say more artistically, the hand carving or hand cutting of the printing plates. Okay, so this is the way we get the let's say the 3D shape of our printing plate. How do we make our printing elements going onto the surface of the plate? Well, we can have an external media, typically a film, of course, an external film that is imaged, or we can image directly on the surface, on the structure of the plate. Okay, so if we have an external media, the external media can be a photographic film. We used to have real photographic films, like negative films, like rapid access films, until some years ago. But today, photographic films are almost disappeared from the market. But we do have thermal ablative films, so we call them digital films, right? Or we can have films made with inkjet printing, where we have an inkjet printer that will print the black and will create a negative image. Or we can work directly on the surface of our photopolymer plate. We will have and we will see the we call the LAMS system, laser ablation mask system. Those plates that we normally call like digital plates, right? So we have a plate with a black layer and we will see how it works. Or directly on the plate, we can have direct engraving. Okay, so this slide is, there's a lot of content in here, but it was just to give you a preliminary introduction of what I'm going to talk today. The evolution of plates started with the evolution of flexography. So the early days of flexography, we're talking of end of 18th, 19th century, the early days of the 20th century, and we are talking of one industrial age where the industry was still trying to find a kind of a settlement, a kind of a method of working. And the first applications of flexographic printing plates were really made by handcraft engraving, right? Then we moved to vulcanized rubber. Then there was the age of photopolymers that came into action, but we are talking already of a jump of several years. And finally, we have elastomers. When thinking about hand cutting, well, we can consider it today rather a form of art. Okay, so when you see there are some block printers around the world, but they use this method of hand cutting or hand engraving just for artistical purposes. But you think that in the past we used to have this activity related to actual industrial production. Of course, we are talking of the production of some graphic objects, very, very simple graphics like, fragile or the sign of the umbrella, just to identify that the package was containing something that needed to be protected. And the message that was given by the flexographic printing was really, really an informative message about the contents of the package. For a very long period, we used to have vulcanized rubbers. It's funny because, even today, if you go to Germany, flexography is still called Gummitruck. So gummi is for rubber, right? So the name of, and in Italy, when you mean the plates, in Italian they say le gomme, the rubbers, because it used to be the major component that was used to make these printing plates with the vulcanized rubbers. And still today we have a restricted number of users doing some very simple printing onto very rough material that need to be either decorated or marked with certain symbols. We have vulcanized rubber thanks to Mr. Charles Goodyear, that we know for tires, probably the name. And in the some years ago, he discovered that adding a certain sulfur to the latex of the rubber, coming from the latex of the rubber tree, combined with heating and time, resulted in a certain resistant and elastic compound, very nice to make printing plates. So after more than 100 years, this process was used to make rubber printing plates for aniline printing. And how does it work? It worked with a plate that was made with a typical letterpress printing plate, with the lead, tin, and antimony leagues of metals, and they were actually pressed against a sort of a carton, okay, a carton that a molding carton that, with pressure, temperature, time, and certain humidity, it could get an imprint of our relief printing plate. So we had this hard metal printing plate that received this imprint. Now, after we take this carton, we can get a piece of rubber, okay, natural rubber or other compounds made of rubbers. In the years, we could see many different rubbers that were developed, like nitrile butadiene rubbers or EPDM, for different resistances, chemical resistances against certain inks. And with the same system, pressing the rubber with temperature, time, and heat, like Mr. Goodyear invented, we could finally get our printing plate. And the printing plate could then be used to be mounted on a cylinder on a printing press. So this method of matrix molding was actually derived from a similar method used in letterpress, where they used to do this molding and to obtain by fusion of these metallic leagues of lead, tin, and antimony to print in rotary letterpress. For the same, with the same or similar system, we could have our vulcanized rubbers. So here, actually, we are talking of vintage or ancient methods for the preparation of a flexographic printing plate. A more modern way of making this printing structure was given by the use of photopolymer resins. The first resin that was used was this liquid photopolymer. Liquid. When we say liquid photopolymer, photo is the prefix photo means that there is something that reacts with the light. Okay, so it's a liquid polymer that could be hardened by the action of an exposure to radiation, and that was UV radiation. So liquid polymer is still used today for the preparation of thick and soft printing plate, especially for the production of corrugated printing, where we need to have a thick plate for our needs. So normally, working with a crystal plate, we had a negative film carrying in negative, of course, the printing images. So I mean, the printing image is transparent and the non-printing is black, covering the emission of the radiation. With the help of a protection layer and with the definition of the certain thickness of the layer that we need to obtain, this liquid resin was poured, or is poured, into this kind of a sink, okay, provided by these thicknesses on the sides, and a protection layer is added, or a base layer is added to the bottom. Well, I say the bottom. You can see it like at the top, but this, we are looking at the bottom of the plate. So the plate here is facing upside down, facing down, masking the non-necessary areas in order to avoid the complete polymerization of this resin. We could then start the process of polymerization. Polymerization means that by the means of this ultraviolet radiation, the polymer hardens. Okay, it hardens and it becomes it looks like a vulcanized rubber. Not exactly, but very similar. And after this, we can remove this plate from the exposure unit, and what you see here, like a still darker polymer, is one area that can be recovered. So this polymer that was not polymerized can be reutilized for future use. Okay, so one good interesting thing of these liquid polymer plates is that we actually polymerize only where necessary, because all the other polymer is then taken back to the container and reutilized for future use in our process. Okay, so here we have some examples of a flexo plate still mounted on a washer, where we are rinsing away the polymer and cleaning better all the printing and non-printing areas.